Let's work through this quiz over simplifying radical expressions, and also there's going to be complex numbers on here. So in these first several questions, we'll be simplifying radicals. And remember, we have 3 rules for simplifying radicals. There can't be any, so no perfect square factors. Within the radical. No fractions in a radical. And no radicals in the denominator. Those were the 3 rules we started out with. We actually kind of added a 4th rule a little later on when we started talking about imaginary numbers. So a negative in a square root becomes an I outside the square root because the square root of -1, it's like factor out a -1. So here we go. These first 6, we just have to check that first rule and the last rule because there's no fractions involved. So when we say no perfect square factors, we're thinking through our perfect square factors, which are 4, 9, 16, 25, 36, 49, 64, 81, 100. So we're checking to see if any of those numbers, which are perfect squares because it's 2 squared, 3 squared, 4 squared, go into the number. So normally they're on the lower end. So we know that 9 goes into 18. So what we do is we split this up into the square root of 9. And then 9 times what equals 18? So that's 2. And then the square root of 9 is 3. So when we take the square root, we don't put the square root sign anymore. The square root of 9 is 3. So we have 3 times the square root of 2. Let's see, number 2, square root of 150. 4 doesn't go into that, 9, 16 doesn't, 25 does. Something ends in 50, 25, 50, 75, or 0, 0, 25 goes into it. So 25 goes into this. And we think 150 divided by 25, that is 6. And so this is, the square root of 25 is 5 times the square root of 6. Number 3, first encounter with a negative. So we know automatically, like right from the start, we can say this is the square root of 392. And technically what we're doing is saying this is the square root of -1. You don't have to necessarily write that step. So this is the square root of 392 times I. And we want to see if any perfect squares go into 392. 4 does. So we could do 4. Sometimes with 392, like a big number like that, we would want to see if any larger numbers go into there. So we might think the 16 or even 36. So we could, or even 49. So I'm going to bring out a calculator here. And we have, move it to the side. What's 392 divided by 4? All right, so that's 98. So we could bring out a 4, but 98, if you're familiar with 98, 49 goes into that. So if 4 and 49 go into it, we can do 4 times 49. Oops. 4 times 49, which is 196, which is a perfect square. We've seen that before. That's 14 squared. So one way to do this, we could think, well, this is the square root of 196. How many times does 196 go to there? So 392 divided by 196 is 2. So the square root of 2i. So this is 14. Square root of 196 is 14 times the square root of 2i. So that's one way to get it. The other way, which we kind of hinted at before, we would still split up into the square root of 392 times I, and we saw that 4 went into that 98 times. And so this is 2. But then square root of 98, we recognized, 49 goes into that. 49 times 2. Square root of 49 is 7, so we have 2 times 7 times the square root of 2i, and so we get 14 times the square root of 2i. It took a couple steps more, but we did use perfect squares that were a little more familiar to us. Number 4, we have 80 here. 80, we know 4 goes into 80. Also, though, 16 goes into 80. So we can write this. So make sure you keep the 4 there. So 4 times, and this is 80 is 16 times 5. So the square root of 16 times the square root of 5. Again, make sure that 4 stays there. The square root of 16 is 4 times the square root of 5. So we end up with 16 times the square root of 5. All right, next one, I'll change color just because I have some stuff written here already. So we'll try to divide this. We have negative 6 times the square root of 72. The negative's outside the square root, so we don't have to worry about the negative. We're allowed to have a negative out there. 72. A couple avenues we could go here. Some might recognize 9 goes into that. 9's a perfect square, so you could do the square root of 9. 9 times what is 72? That's 8. So we have negative 6 times 3. However, the square root of 8, now we're like, 4 goes into that. So we can write that as the square root of 4, because 4 is a perfect square, times the square root of 2. So right now we have negative 18 times 2 times the square root of 2. So that's negative 36 times the square root of 2. Now, some of you might have realized to start with, 36 goes into 72 twice. So you could have done negative 6 and realized it's 36, which is a perfect square, times 2. Negative 6 times 6, because the square root of 36 is 6. And just another way to get the answer. And number 6 is our last one that does not involve fractions. And this is actually a really easy one because we know the square root of 36 is 6. So this is just negative 8 times 6, which is 48. Sorry, negative 48. That's it. All right, once we get to fractions, we still know we can't have perfect squares in the factors. So let's move this down. And we have a negative here. So whenever we see a negative, we can jump right to writing that this is square root of 9 times I over the square root of 16. And this one is also simple because we know the square root of 9 is 3. So we have 3I over the square root of 16 is 4. So 2 perfect squares. Well, number 8 is very simple as well because those are both perfect squares. So the square root of 9 is 3 and the square root of 4 is 2. Number 9. Square root of 15 can't be simplified. Square root of 4 is 2. And this answer is in simplified form. We don't have fractions in the radical, and there's no radicals in the denominator, so this is our simplified form. When we get to number 10, we do have to consider step 3 here. Now, first thing, it is often nice just to simplify first here. So the square root of 4 is 2 over the square root of 3, but we still have a radical in the denominator. So if you remember, what we did to rectify that was to multiply by a special form of 1. We multiply by the square root of the radical that's in the denominator. And when we do that, we have 2 times the square root of 3. We don't combine those. We don't do 2 times 3 is 6 because 3 is within the square root. And then remember, the square root of a number times itself is just the number that's underneath the radical. So the square root of 3 times the square root of 3 is just 3. That is our simplified form there. Remember, the 3 and 3 do not reduce because one's in a radical and the other one is not. Number 11. Number 11, again, we can automatically remember there's a square root under the radical, so there's a negative under the square root, so we have to bring out an I. This one, within the square root, there's a 6 and a 10, both under the square root in the fraction, so we can reduce by 2. So this is 3 and 5. I'm going to go ahead and rewrite that just so we're not working with crossed out things here. Well, this still is not simplified because it has a square root in the denominator. So now we have to multiply by the square root of 5 over the square root of 5. Move down here. Square root of 3 times the square root of 5 is the square root of 15. We still have the I. And remember, the square root of 5 times the square root of 5 is just 5. Also a reminder, we cannot cancel the 15 and 5 here because the 15 is in the square root and the 5 is not. Number 12, this negative, we don't have to use I. It's not under a square root, so that's okay. I shouldn't have put equal yet. We can't have that square root of 2 in the denominator. So we are going to multiply by the square root of 2 over the square root of 2, which gives us negative 3 times the square root of 2 over the square root of 2 times the square root of 2 is 2. So that wraps up those first several questions in the review.